Okay. So now this is going to be our modulator, which is sequence generator, generating the bits, line encoder, going as an input to multiplier, and this is going to be our carrier. Okay, we need a phase shifter here. And this is going to be our demodulator, where you have a multiplier. The output from here goes as an input. We will multiply it with the same carrier, and we'll ensure that the carrier that is used in the modulator and the carrier that is used in the demodulator are same. If they are not same, we'll use a phase shifter to correct them. That goes as an input to low pass filter, and then decision maker, line decoder. One more. So there you go. This is your phase shifter in the transmitter, and this is the phase shifter. Let me just put it back over here at the receiver. Okay. All right. Let us start with the modulator. Okay. So obviously I will try to use maximum high frequency carrier. Okay. The input, the signal analog output of the oscillator goes to phase shifter, and the phase shifter goes as an input to multiplier. Then sequence generator generating bits goes as an input to line encoder that gives me the pulses output. I'm going to use NRZL. There are many line encoding techniques. Each of them have their own advantages and disadvantages. All right, we'll not go through that in this review. And this output goes as an input to your multiplier, right? Remember, we said that we have to make sure that the bit clock is 4 times the carrier, like the time period of the carrier, right? So in order to ensure that, we take the TTL output for the carrier oscillator, and it goes as an input to M clock. Okay, and line encoder has a multiplier that is happening over here that gives me my bit clock. Okay, and this bit clock will be used in any module where it needs a bit clock. Okay, for example, the sequence generator needs a bit clock, so this goes as an input to the sequence generator. Okay, now this is my modulator, right? In the demodulator side, the multiplier output goes as an input to the multiplier in the demodulator. The carrier that is connected as an input here, okay, let us assume that this is we'll use the same carrier, but we'll let it go through a phase shifter. Okay, this will ensure that the phase of the carrier at this point and the phase of the carrier that was used here are same. If there is a phase difference, it will lead to incorrect detection. Okay, incorrect decoding. All right, so we'll use this phase shifter later on to ensure that they are of the same phase. Okay, then the multiplier output goes to low pass filter. You can put the tune to the highest because it's a pulse. Let me have as much harmonics as possible, right? But still I will not be able to get a good square pulse because some of them will be lost. It's a low pass filter. The output goes as an input to decision maker. The decision maker output goes as an input to line decoder. Because we use NRZL, we'll use NRZL here. And finally, the output that you get from here is your transmitted bits, right? In order to make it easy, the bits will be represented as pulses also, so that we can see it on oscilloscope. Okay. As we agreed, we're going to look at the output using yellow wires, right? So we look at the output after the multiplier. Okay, the modulated signal. We'll see the output with respect to NRZ data. Okay, all right, this is my line encoded output and this is my modulator output, right?
Again, this one.
This is my line encoder output, and this is my modulator output. We'll look at the output after the multiplier in the demodulator. Then we look at the output after the low pass filter. Then we look at the output after the low pass filter and decision maker. And finally, we'll see what we received in the demodulator, right? Okay. Remember, any digital modulation module, for example, decision maker, line encoder, line decoder, needs bit clock. And the bit clock comes from, as we agreed, from the line encoder, right? From the beginning. So the line encoder goes as a bit clock to decision maker. The same bit clock goes from the line encoder as an input to line decoder. Okay? So our connections are ready. Alright?